Okay, really most of what we're learning in logarithms in real life would be to solve exponential or logarithmic equations. And so most of what we've been doing really is to kind of get to here. All right, so if you were given that first example, solve 54 equals 3 to the n, and what are you going to do? I mean, you know 3 squared is 9, you know 3 cubed is 27, you know 3 to the 4th is 64. So we are somewhere between 3 and 4. So how in the world are you going to find that value? And that's the question. How are you going to do that? If I change this thing into a logarithm, right, and logarithms are exponents, I get this. Log 54 in base 3, right? So I'm going to take my calculator. I'm going to figure out the value of that. And some of your calculators are dumbing you down and might even have a button, which would be really stupid because you really need to figure out what you're doing. But the value then is 3.6309. And notice I went to 4 places because it's an exponent. Now again, it keeps going even past that. But if you do 3 to the 3.6309, you're going to get 54. Okay. And our calculator's able to determine that. Okay. That's the idea and that's the concept. And so, same idea here in the second one, really, really similar. You know, again, what is the exponent n? 53 in base 7. And again, if you know how to use your calculator, and you know what's going on here, you can figure out the value. And that one is 2.0403. 2.0403. If you know what to do with your calculator. And honestly, it's pretty easy. So I got a box and I got 2 stars, and all you got to do is just remember this formula. Really, really easy. Take the common log of the A. Take the common log of the A and divide it by the common log of the B. So take your calculator and do the log of 53 divided by the log of 7. Take your calculator, do the log of 53 divided by the log of 7. You should get 2.0403. Log of 53 divided by the log of 7. Everybody should have their calculator out. Everybody should be calculating. Log of 53 divided by the log of 7. Let me see if you're getting that. How many are you getting that? Okay. Questions? So as long as you know the formula, and look, the formula is easy. Quite honestly, isn't the A really above the subscript B? So it's even in order. The log, common log of the top one divided by the common log of the base, the bottom one. That's it. It'll give you the value. Nice. Sweet. Piece of cake. No sweat. So you got to know the formula, but the formula is easy. All right. So let's do some problems. So go ahead and do A and B. And if I were you, I'd just take a second. Look, it takes a second to write out what you're doing, right? I mean, wow. That was probably 4 seconds, right? Gee, that'll... But every time you write it again, you're going to help to wire it in your brain. And you got to wire it. You got to fire it to wire it. It depends on your calculator whether you can hit the log button first and then the 39, or the 39 and then the log button. Then you got to do divide, and again, it depends on your calculator syntax as to which way you're going. I got 2.2763. Be careful you pour around off people. 2.2763 is that one. Alex, did you have any of these on the test yesterday? Really? What a bummer, man. No good stuff on there. A lot of geometry?
Yes.
Yeah, that's unfortunately usually the Achilles heel. All right, so 2.801. Everybody okay with those two? Just common log button. Common log of 845 over the common log of 11. Voila. Calculator button. You're there. No questions. All's good. Okay, so, again, these are pretty boring. So you look at C. Oh, wait a minute now. What in the world do I do now? What do I do? So what would you do with C? I heard change what? Change it to logarithm form, right? So as long as you know how to change the logarithm form, you are good to go. Logarithms are exponents. Right? And that's all it is. Same idea. And by the way, it doesn't hurt to ask, does my answer make sense when you're doing these things? 7 to what power has to be 350? 7 squared is 49. I don't even know what 7 cubed is, but you got to be in that ballpark. So 3.0104. Anybody concur? Is there life in the rest of you? Is there life out there? Hello, hello, hello. Anybody there? There. All right, just wondering. Okay, so go ahead and do D, and I'll do it while you're doing it. D I just wrote right out with the change of base formula. You can do it the other way if you want. Esther, what do you think for D? I agree. 8.4004. No sweat. Piece of cake. Life is easy. Life is grand, right? They're easy. Okay, so don't let something like E trip you up because it's still the same concept, right? Same idea. So let's go ahead and change that to logarithm form. Do you agree 2x equals log 2 in base 3? So see if you can finish it. I'm going to pause. All right, on 3, give me your solution. 1, 2, 3. All right, I think I heard 0.3155. And all you're doing is solving that little equation. A couple different ways you can do it. So I turned it to log form, divide it the other side by 2 to move the 2, right? Got my variable isolated. Now I got to do the common log of 2 divided by the common log of 3 and then divide everything by 2, right? And voila, you are there. So change log form. Move the 2 by dividing the other side by 2. Just keep track of your numerator and denominators. And you got to make sure you punch that in correctly your calculator, and voila, you are there. So you can see D is similar. A similar situation. So go ahead and do D. Again, I'll do it up here while you're doing it. If you get stuck, look up. If you know what you're doing, just try to keep going if you know what you're doing. And does the mams like your answer? You figure 8.8 minus 7, that's a 1 point something, 5 to the 1 point something, giving me a 20. Yeah, I like that, right? Because 5 squared is 25. And we like our answer. So again, you got to know how to change from exponent form to log form to be able to do this. Destiny.
Wouldn't you round your answer to 5 to a 4 to be 8.861?
8.861. Do you think that's a 4? All right, I concur. I give it to in. I'm not even going to look. It's not worth the effort. Be careful, you round off people. All right, beware. All us round off people, beware. Any other questions on that? Okay, so those are straightforward. Listen, that formula is definitely good for a question or two on the ACT, SAT. Guaranteed, or your money back. There's always a change of base problem on the SAT, ACT. Or something like this where you got to use the change of base formula to solve it. And it's a pretty simple thing if you can remember that logarithms are exponents. And therefore then be able to change to exponent or to log form and solve it. And again, the change of base formula really, really easy. All right, number 2. To solve exponential equations, take the log of both sides or change the log form. So I'm going to show you 2 methods. We've already done the change the log form method. I'm going to show you the second method, taking the log of both sides. You might say, Mr. Scarfi, why 2 different methods? I like just changing it to log form. That's easy. Yeah, well, unfortunately, you can't solve every problem that way. You can solve every problem by taking the log of both sides, but you can't solve every problem by changing it to exponent form. My preference is I just show you the one, but again, some like both, and there are times you use both. So let's go through, we use both. So in the first one, on the left, if you were going to take the log of both sides, what you're doing with this thing is you're taking the log, and I shouldn't, here, let me move that down a little bit. Whatever the base is, that's what you need the base of your log to be. So it's 5 to the x, so I'm going to do log base 5. Then comes your 5 to the x, and then it equals, and I got to do it to both sides, the log base 5 of the 29. So you're taking the log of both sides. So it's a log base 5 of the left, log base 5 of the right. Whenever the result, the number, equals the base, that's 1. So that green box is 1. Therefore, then, you get just the x. And so you end up with x equals, and again, now you're ready to use the change of base formula, log 29 over log 5. It's by taking the log of both sides. Now, I know what some of you are saying. Wait a minute, isn't that just changing the form? Yeah, on this one. So again, that's why the or. So again, the left side was taking the log of both sides. The right side is changed to log form. Oh, and by the way, I never finished the blanks, right? And use the change of base formula. Right, that change of base formula is always going to come in. So on the right, again, if you just change the form into log form, then we know that this is x equals log 29 in base 5, right? And again, we're at the same place. Going to do the common log of 29 divided by the common log of 5. And I guess our final answer in this thing is going to be 2.0922. Did I round off right that time? Thank you, Destiny. 2.0922. two different ways of approaching the same problem. The left way will solve every situation. The right side has limitations. Left will solve everything. Right has limitations. Right is easier, per se. So when you can, most students will use the right when they can, use the left when they have to. All right, let's do a few more. No problem. So if I were going to take the log of both sides for b, what would I do? Log what of both sides? Log in base 8. So most of the time I just do it right up on the original, and I tried to leave you guys enough space to do that. So again, whenever the result, the number equals the base, it's 1, and you get the exponent. So now we end up with x minus 1, and I can go right into the change of base formula if I want. Common log of 12 divided by the common log of 8. And oh yeah, things added to the variable, you move by adding their opposite to both sides, and you finish it off, right? .1950. 2.1950. Okay, just order of operations from here. You got to do the division first, then add the 1 when you're done, and voila, you are there. And again, same thing if you change the base. I'll do one more of these, but you know, again, what is this? And this is log 12 in base 8, right? Same place. Same place. I don't know if you now have caught on that the change of base formula is literally simply a shortcut to taking the log of both sides. It's really, that's where it came from. Where did the change of base formula come from? It's a shortcut for taking the log of both sides. That's all it is. Okay, so all of these still we can do both ways. Let me go higher here. So C, no problem. All right, same thing. And then we'll get to D. So C, again, you start speeding up here. It's got a little bit more to it. Oh, oops. Log 4, log base 4, right? And again, what's the right going to be when you use a change of base formula? Log 11 divided by the log of 4. Hey, let me just remind a few of you guys how to finish this problem. Everybody agrees to that step, right? 2n minus 1 equals common log of 11 divided by the common log of 4. So look, from day 1 in pre-algebra, I said this to you. When things are both added to and multiplied times a variable, move things added first. So hopefully you agree we're going to add the positive 1 to both sides, right? So that then to move the 2 now, you're going to do this, everything up there, right? The whole side divided by 2, right? So the numerator is log 11 divided by log 4 plus the 1. You're probably going to have to hit enter in your calculator and then divide by the 2. Okay? So again, if you're doing that in your calculator, log 11 divided by log 4 plus 1, and I would hit enter, total it out, then divide by the 2, if you're going to get that correct. Anybody got it? Keegan, what do you got?
1.3649.
Yeah, that's what I got, 1.3649. So make sure you can get that on your calculator. Make sure that you know the sequence to punch that in. I'm not going to do the other form there. It's the exact same thing. You end up in the exact same place, right? And what's the big deal in D? We're not even going to finish it. It's just knowing our exponent rules, right? To do D. So we know that D is 3 to the 10n, right? And now we're ready to take the log base 3 of both sides. And again, I don't know that I'm going to finish it, but you'd end up at 10n equals common log of 0.1436 divided by the common log of 3. And again, you're going to divide all of that by the 10. And you're there. You've got to be able to do the problems on this page. And you'll have numbers of them on the test next week and on the quiz next week. Okay, so you got to do this. You got to be able to do that. Any questions on any of those so far? So the change of base formula is really nothing more than taking the log of both sides. But that's a key cog in solving these. Okay. So what happens with E? Oh no. I have exponents on both sides. That begins to get tricky trying to do the exponent, trying to change it to log form. It gets tricky. So instead of that, we're going to take the log of both sides. And again, you have to say, do I want to take the log 5 of both sides, or do I want to take the log of 7 both sides? I'm going to do log base 5 of both sides. Everybody okay with that maneuver? Right? Take the log of both sides, and we'll use base 5. So our left is 3n minus 1. But our right, and by the way, give yourself a little space before you write log 5. 7 to the eyes are failing me, 4n. Okay. Okay. What would you think is the next maneuver? Don't say anything out loud yet. Because, okay, now we're back to pre-algebra again. What do you do when you have variables on both sides? Get them all on the same side. Well, we're a couple steps before we can get all the ends on the same side. So looking at this thing, what's the next move? Anybody? What's the next move? Abigail, what's the next move? Power rule, right? This 4n is an exponent, and it can come out front, right? So here, let me go slow with this one and try to make sense for it for you guys. So here's where we're at right now. And is it okay if I use a parentheses here, and let's use the log 7 over log 5? Is that okay with everybody? Because isn't the 4n times that? Okay, so we have 3n on the left, and we have a 4n multiplier on the right. So do you want to move the 4n from right to left, or the 3n from left to right? You definitely want to move the 3n from left to right. Okay, you definitely want to. So we're going to add a negative 3n to both sides. You okay with that? This is just algebra, right? And it's just elementary algebra so far. We moved the 3n by adding a negative 3n to the left and a negative 3n to the right. Okay, so now you got to know what to do. What do you do with the 4n times the common log of 7 divided by the common log of 5 minus a 3n? What do you do there? I hope you're thinking. Think. What would you do? Remember, we're trying to, like solving any equation, isolate the variable. So how do you reconcile that? What's the key step right now? Anybody think they got it? Julia, what do you want to try? That would, and at least you're thinking, that would move it from here per se, but wouldn't deal with this. It would apply it to this, because you got to do both sides by it. So you'd move it from here to here. So this will still be stuck over there. All right, what's the key move here? Destiny. Yeah, didn't you?
I was thinking.
Oh, you were thinking. All right, you had your antenna up. Now I got it. Looked like your hand was up. I guess you were trying to get the brain waves that are going through the room here. Come on, what do you do? Okay, let me make it more simplistic. What if you had a problem like this? Whoops, I have X's and N's. Make that a 5. We've done these. What's the next step in this problem? Factor out the common n, right? It's the same problem. It just looks different because it's got a logarithm in there, and we're like, I don't know what a logarithm really is. It's just algebra. It's just algebra. Factor out the common n. Well, you got a 4 times a log 7 over a log 5, and you got minus a 3. So what? You're just punching numbers in the calculator. Just took the common n out, right? And now what do? Shove all that junk where? Down in the bottom, right? You're just going to divide the other side by it. Just going to divide the other side by all this junk right here. That's all. So you got to be careful punching this into your calculator. You got to really be careful punching this into your calculator. So you got a -1 divided by, and you got to use a parentheses here in the bottom because this is all one term. A 4 times the common log of 7, divide that by the common log of 5, and then total that and subtract 3. I would use double parentheses if this were me. I would do parentheses, 4 common log of 7 divided by common log of 5, close parentheses, minus 3, close parentheses. That's what I would do. But you got to learn how to punch it. Because if you can't punch it, then you can know what to do and not get the correct answer. Hopefully I punched it right. I got -0.5446. Anybody else get that? Okay. -0.5466 equals n. No, it's just algebra. It's just algebra. You say, but I would have never known to do all that. Yeah, that's why they pay me, right? And that's why I showed it to you. Okay, so let's do the same thing in F. And you'll see you start doing the same things. You say, but Mr. Scarfi, I would have used log base 2. Fine, knock yourself out. It'll still work. Do log base 2. So I get 2x plus 1 equals, and look, once you start doing them, why don't I just do the power rule right now? Put the exponent out in front. You okay with that? And I'm going to use a parentheses, right? Because doesn't the exponent come out as a multiplier? I'm just going to put this out. That's a 5, huh? I can see it better on there than I can on my screen. So I'm just going to put that out front, and now we have, and I'll just leave this for now, log 2 in base 3, right? Do you agree? Just use the exponent rule. Power rule. Okay, now we got exponents everywhere. On this one, you got to distribute. So it's x times log 2 in base 3, right? And then I'm going to do the 5 in black. Plus 5 times log 2 in base 3. You know, why did I do that? Because I got to get to that x, right? I got to get to that x. And therefore, I had to get things separated. Okay. Do you see at this point your variables here with the 2 and your variables here with this log 2 in base 3? So you either got to move this to the left or this to the right. Doesn't really matter. Whichever one. Either got to move this left or move this right. So let's move this left. And while we're at it, should we put the 1 on the other side? Let's put the 1 on the other side. So your left's going to be 2x minus x log 2 in base 3 equals, we still have the 5 log 2 in base 3, and now we just added a negative 1 to both sides, so we got a negative 1 on that side. So now key step is to do what? Factor out the common x, right? Here, I'm just going to cross, well, I crossed out my 2. Just going to cross out the x, put a parentheses, and put the x out in front, right? I just factored out the common x. And what do you do with all the junk that's multiplied times the x? Put it down below. You're just dividing the other side by that, right? It's a multiplier of the variable. It's just, the other side gets divided by it. Now you're just punching numbers. All right, so when you get time and you play with that, hopefully you get 1.5738. I don't know if anybody could punch it yet. That one's a little bit complex to punch. Again, I'd be careful, and sometimes you got to use double parentheses, because again, this whole denominator is, this whole thing is the denominator. Again, I would use a double parentheses. Parentheses 2 minus parentheses natural log 2 divided by natural log 3, close parentheses, close parentheses. Because again, your calculator's got to know that this is all one thing, right? This is all the bottom. Anybody get 1.5? Okay, so you guys can play with that later on. You got to make sure you can punch that though, and that you learn how to put it in your calculator. Look, that may look weird, but that's definitely doable. All right, I want to do one more problem here. Carbon-14 has half-life 5,730 years. Piece of wood contains 7 grams of carbon-14. Predict how long it will take for there to be 6 grams of carbon-14. Carbon-14 decays. Now, we're going from 7 to 6. Do we have less than half of it gone? Yeah, we only lost 1 gram out of the 7. So we better end up less than 5,730 years. There are the two formulas, which, by the way, this should have been capital T there. That's half-life. Right? T over T. The first formula uses a 2 base with a negative exponent. The second formula uses a half base with a positive exponent. It's the same formula. 2 to the negative 1 is 1/2. It's the same formula. Some like this one, some like that one. Show it to you both ways. Let's use this one. So what goes in for f of x? Say it if you know it. Now, by the way, last chapter, we've already talked about what things are in what position in exponential functions, right? So what number of all this goes where the f of x is? The 6. The 6. What goes where the a is? What is the a? The what amount? The initial amount. All right, so if you remember that, now look, 2 weeks ago you remembered that. You don't remember it anymore. That's your problem. Now I can teach you stuff, but you have to review it enough to remember it. Because 2 weeks ago you knew that. 7's the initial amount. Okay, that's the 7 grams. 1/2. T is what we're looking for, right? And the half-life is 5,730. Oh, we got an exponential equation. I think we'll use logarithms to solve it. Okay, in this problem, I'm not ready to take the log base 1/2 of both sides yet, because the 7's in the way. You got to move the 7. Hopefully nobody has a problem doing that, right? Move the 7. Divide both sides by 7, multiply both sides by 1/7. 7's moved. Now, I can take the log base 1/2 of the left, log base 1/2 of the right. You guys want to use 0.5 for 1/2? Let's use 0.5. So now I got log 6/7 in base 0.5 equals t over 5,730. Agreed? I mean, that's not hard. We moved the 7, we took the log base half of both sides. Okay. Move the 5,730. That's not hard, right? Things on the bottom go to the top. You're just multiplying both sides by 5,730 times that. How in the world do we do log 6/7 in base 0.5? We use the change of base formula, right? So what is this? 5,730 times the common log of 6/7 divided by the common log of 0.5, right? I'll write it out. 5,730 times the log of 6/7, that's the top, and the log of 0.5, common log of 0.5 is the bottom, right? Change the base formula. Top thing is 6/7, the bottom thing is 0.5. That's all going to equal t. And I got 1,274.3 years. A little bit older than even me. All right, 1,274.3 years. Makes sense, too. We didn't get rid of half. And the ratio's there. All right, 1, 2, 4, 6 through 12, etc. Look, I'm on a schedule with ODAX next week, so if by some miracle we're out tomorrow, there will be a video. So just be aware and make sure you got your books home, make sure you got your notes home. If by some miracle there will be a video on HCS math class. It's going to allow me to review Monday, quiz Tuesday, test Wednesday. This is the last. Wait, we got one more lesson. Yeah, that lesson. Then review Monday, quiz Tuesday, test Thursday, Wednesday.